All right, we're on day 21, where we're going to do just a whole bunch of problems for your assignment. Now, because those problems are all consecutive in your packet, you will be able to do them right in the big packet. You don't have to do them on a separate sheet of paper. You only had one homework question, question 33, so have that out. And also be having your calculators out. So we'll leave this up here for about a minute for you to check your answer, and then we'll talk about it a little bit and also have your calculator out. All right, we just want to find the volume of this whole shape. We have a cylinder and a hemisphere, which is half a sphere. So first off, the diameter of the cylinder is 8, which allows us to determine its radius is 4. Well, the radius of the hemisphere will be exactly the same. So the hemisphere radius is 4 as well. Because the hemisphere radius is 4, we can take that off of the entire figure's height of 13 to get that the cylinder's height is 9. If you go to your reference sheet, a full sphere's volume is 4/3 pi r cubed, so we just need to multiply by 1/2 out front, and that'll give us our hemisphere. We'll fill the 4 in for the radius. And then we'll add on the cylinder's volume, the 4 pi r squared plus, or 4 pi r squared times the height. So the radius was 4 and the height was 9. We were rounding to the nearest cubic meter, meaning we can put the pi right in. And to the nearest whole, that means the 4 is below a 5, so it stays the same. So 586 meters cubed. All right, we need to go to page 131, number 32, or 33, I guess. So I had listed on your calendar that we were starting with question 32, but we had already done 32 the other day. So it's 132, number 33. That's the first question that we're doing. So we've got a campground map. You got campsite C, first aid station is F, supply station is S. They all have straight paths between them. And then the tower is T. They tell us that FS is 400. Our angle formed by the path, we have 72 degrees, and the angle formed for TC and CS is 55. So everything is already labeled in the picture. So we want to find the distance from the campsite to the tower, which would be this distance right here. Now, the easiest way to do this is to do a law of sines. Law of sines allows you to find sides in non-right triangles. First thing we want to do is we're going to find every angle in the picture. In this smaller triangle, we have a 90 and a 72. So to add the 180, that angle's got to be 18. We're going to find the angle next to the 72 by angles on a line. 180 minus 72 gives us 108. And then in the left-hand triangle, we have a 55 and a 108. So the missing angle there has to be 17 to add up to 180. So when we do law of sines, we can do a side over sine of the angle equals side over sine of the angle. Capital letters represent angles, lowercase letters represent the sides across from those angles. And you could flip that too. You could put the sines on top, the sides on the bottom. Doesn't matter. You'll get the same answer either way. Well, what we're going to do is we're going to find the side that these two triangles share. I'm going to call it y. So we're going to start with y, and working in this triangle here, the angle across from y is 90. So we're going to do it over sine of 90. And that equals, we'll now take the side that we know in that triangle, the 400, and we'll put it over sine of 18. And what we're going to do is we're going to cross multiply and solve for y, and then we'll just do law of sines again in the left-hand triangle so we can find x. So we're going to have sine of 18 times y equals, if we multiply those other two, we end up getting 400. Now you'll learn next year that sine of 90 is just 1. That's why sine of 90 times 400 is 400. So now we'll divide both sides by sine of 18. And we'll have y equals, and we'll give you a moment to punch that in your calculator. And note, that's not going to be our final answer. So we do not want to round that. So again, go ahead, punch in your 400 divided by sine 18. Because we're doing a question with sine, cosine, or tangent, make sure it says DEG on your calculator in the top right. And we should get 1294.42 ... That shows us that we're keeping it out in our calculator. So now let's just do law of sines with the left-hand triangle. So we just found the y. So let's start with the 1294.42 ... over the angle across from the y would be the 55. So we're going to do sine of 55 equals, and now we're going to do the side we're looking for, x, over the sine across from it, sine of the angle across from it, so sine of 108. So when we cross multiply, we're going to get x times sine of 55 equals that 1294.42 ... times sine of 108. And then to get x by itself, we'll have to divide by sine of 55. So in our calculator, we should go up and select the 1294.42 and change. So scroll up, highlight that in your calculator and hit enter to bring it down. Then we'll do times the sine of 108, and then divide it by sine of 55. And we'll give you a minute to put that all in your calculator, and then note we are rounding to the nearest foot. So we should get 1502.86 and change. Nearest foot, that's the nearest whole, so we want to look at the first decimal point, which we have an 8. It's 5 and greater, so that tells us to round up. So we have 1503, and our units were feet. Now, law of sines is just one way to do this problem. Let me just talk briefly a second way you could have done it. We could have used this first triangle and done SOHCAHTOA to find the side that's opposite 72. And then you could have taken the big right triangle and now that we have that starred side, you could have done SOHCAHTOA again to find the value of x. So if you were going to do it that way, you would have done a tan 72 equals, I'm going to call it z, over 400. You would have found what z is. Z would be some number. And then you would have done, from the 55, you would have had opposite and hypotenuse. So you could have done sine of 55 equals whatever the number was for z over x. and then you would have cross multiplied and solved for x. So it's 2 steps either way you do it. It's really just your preference of how you see it to do the problem. All right, going over to 34. Shay has recently begun kickboxing, purchased training equipment modeled in the diagram below. The total weight of the bag, pull, and unfilled base is going to be 270 pounds. The cylindrical base, we've got 18 inches tall with a diameter of 20 inches, which they labeled. The dry sand used to fill the base weighs 95.46 pounds per cubic feet. And we want to know what is the total weight of the training equipment to the nearest pound if it's filled to 85% capacity. Well, notice that in our units, we have pounds per cubic foot, and these are in inches. So first thing we want to do is switch them to feet. We'll divide by 12, and we will get 1.5 feet for this one. 20 divided by 12 will give us 5/3 feet for the diameter. Now eventually we're going to need the radius, so if we do 5/3 divided by 2, that means our radius is going to be 5/6 feet. So our first goal is to find the volume of the entire base. It is a cylinder, so we can go to our reference sheet. Volume is pi r squared times h. So we're going to have volume equals pi. We'll have 5/6 squared, because the radius was 5/6, and times our height of 1.5. And we'll give you a moment to punch that in and get that in your calculator. So that should give us 3.27 and change feet cubed. Well, now we have to convert that to pounds. So we have 3.27 feet cubed. To get rid of the feet cubed, we're going to multiply. Next time feet cubed shows up, it should be in the denominator. Well, we're going to use the density they gave us of 95.46 pounds per 1 cubic foot. So 1 foot cube is going to go over here, and we'll have 95.46 pounds. The feet cubed units wipe out. This is now a pounds. But this is if the base was full. We wanted the base to only be 85% full, so we're going to then multiply that by 0.85, and this will tell us the pounds when it is 85% full. I forgot to put my ... here to show that we're keeping the 3.27 out. Now, 95.46 over 1 is really just 95.46. So we're going to give you a minute, scroll up in your calculator, select that 3.27 and change number, and then multiply it by the 95.46, and then times the 0.85. That should give us 265.53 and change. And this is still a pounds. Not rounding yet because this isn't our final answer. This is the weight of the sand that's inside the base. We've got to still add on the weight of the bag, the pull, and the unfilled base. So we've got to add on the 270 now. So go ahead in your calculators, add that on, and then that will be our final answer, so we can round that to the nearest pound. And when we do that, we get 535.53 dot dot dot. So the nearest pound, that's 536 pounds. All right, going over to the next page, 35. We're given that the big shape there is a parallelogram. We got some perpendicular lines, and we want to prove this. The inside one is a rectangle. So when you do a proof, first thing, do statements and reasons, get down your givens. So we have parallelogram ABCD, and we have BF is perpendicular to AFD, and also DE is perpendicular to BEC. And those are both given. Now note, even though they have the box drawn in there, we've still got to talk about that in our proof. So let's maybe start with the perpendicular lines. We'll do perpendicular lines implies right angles. I'm going to number all of them so they're easier to talk about. We're pointing at right angles, so we'll just say that they're right. Angle 1, comma, angle 2, comma, angle 3, comma, angle 4 are right. And then automatically next, we want to do right angles implies congruent angles. So we'll have angle 1 congruent to angle 2, congruent to angle 3, congruent to angle 4. We set it in our proof, so let's go up and mark it in our picture. We'll have our boxes on all of those. So we're going to try and get the triangles congruent. In our triangles, let's get those two angles congruent by parallelogram implies opposite angles congruent. So we'll do parallelogram implies opposite angles congruent. And we can name those with a single letter because there's only one angle happening there. So angle A congruent to angle C. We set it in our proof, so let's mark it up in our picture. So we now have angle, angle in those triangles. So we need a side. Well, something that a parallelogram implies is opposite sides congruent. So we'll do that reason next. Parallelogram implies opposite sides congruent. And we don't know if we'll need both of them, so let's go ahead and do both sets. We've got AB congruent to CD, and then we've also got AD, that whole bottom side, congruent to BC. So let's mark that up in our picture. I'll put one tick mark on AB and CD, and then we're going to put a big bracket and put two tick marks on the other ones. So here's our plan. We're going to get the triangles congruent, and we'll do congruent triangles implies congruent corresponding parts to get those vertical sides of BF and ED congruent. But then let's also, within congruent triangles implies congruent corresponding parts, get AF and EC congruent, and we can subtract those off from the top and bottom parallelogram side to get our top and bottom side in the one we eventually want to be a rectangle. So in our triangle, we have two angles and a side not in between. So we're going to have angle, angle, side, congruent to angle, angle, side. We'll name our first triangle ABF. And then you always have to be careful in the second one. If we started with A, that was the opposite angle, so we got to go C next. B was that tiny angle, so that matches with D. And then we finished with E. We'll now do our congruent triangles. Implies congruent corresponding parts. And we're going to get BF and ED, those vertical segments. And then we'll also do those little horizontal ones. So AF congruent to EC. We set it in our proof, so we'll mark it up in our picture. I'll do 3 tick marks on each of those. And I'll do 4, oops, not that. We'll do 4 tick marks over here. So we're now going to do our subtraction postulate. We're going to take our 2 mark side in purple and subtract off our 3 mark side in red. And that'll give us another set of sides in that interior one we're trying to eventually get to be a rectangle. So we'll do our subtraction postulate. And we're going to take our big one, AD, minus the little one, AF. That's congruent to the big one, BC, minus the little one, EC. And then we'll rename what they become. AD with AF taken off now gives us FD. BC with EC taken off now gives us BE. We set it in our proof, so we'll mark it up in our picture. FD congruent to BE. Got 5 marks now. And now in that interior one, BEDF, we've got 2 sets of opposite sides congruent. So we can make that be a parallelogram first. So we can say both pairs of opposite sides congruent implies parallelogram. And we can say that BEDF is a parallelogram. Well, we want a rectangle. We have a parallelogram, but we also have that already shown that there's a right angle in there. So we can say a parallelogram with a right angle implies rectangle. And we can finish it off by saying that BEDF is a rectangle. The other common way you can sometimes show up a rectangle is a parallelogram with congruent diagonals. But we didn't have diagonals here, so we didn't have that as an option. All right, one last one. The rest of the ones you're going to have to do on your own for homework are all going to be multiple choice. So we're going to look at just number 9, which number 9 is if you flip ahead to page 139. So they give us some expressions. We eventually want to find this angle here, BAC. What this question wants us to use is our exterior angle theorem in triangles. An exterior angle, which is formed by extending one of the sides of a triangle, is always equal to the sum of the 2 interior angles next to it. And the reason that is the interior ones are adding with that starred angle to get to 180, and your exterior angle is also adding with the starred one to get to 180. So we can set up an equation of 180 minus 3x equals 6x minus 40 plus x plus 20. We can combine like terms on the right side, and we'll have 7x minus 20. I'm going to collect all my x's on the right, so I'll add the 3x over. We'll have 180 equals 10x minus 20. We'll add the 20 over to give us 200 equals 10x. And we'll divide both sides by 10 to get 20 is equal to x. Always, always, always on this test, do not circle an answer immediately when you solve for a variable. Always reread the question. They did not want us to find x. We want to know that starred angle BAC. So let's take that 20. Let's sub it in here. We're going to have 180 minus 3 times 20. That'll end up giving us 120. Well, these two angles are on a line. So if we do 180 minus 120, that will now give us 60 for the angle that we're looking for. So choice 3. Always, once you find a variable, reread the question, see if you need to sub in or find something different. Don't just automatically circle the number you got for that variable. So any time remaining in the period, you could be working on the rest of those assignment questions, and any you don't finish are your homework due next class. Have a great rest of your day.